Hello. So in this lecture, I'm going to discuss about a very interesting topic that is known as Booth multiplication algorithm. Now, the question is when to use the Booth multiplication algorithm. Suppose if I have given some signed number and I have to multiply the numbers, then I have to use Booth multiplication algorithm. So Booth multiplication algorithm is specially designed for the multiplication of signed number. If you have unsigned number, then you can easily use uh, array multiplier to get the multiplication result in digital electronics. But if you have given signed number, then you cannot use array multiplier. In that case, you need to use Booth multiplication algorithm. Okay. Now, uh, the question is how to do the steps in Booth multiplication algorithm. So you can see here, you need to start the process. Then you need to decide the value of means you need to decide the value of Q0 and then N and then A0. Now, what is Q0, N and A? I will tell later on, but let me tell you what is M and Q. So capital M and Q are nothing but multiplicand and multiplier. So what are these things? Suppose if you are given a problem where you need to multiply -5 with 3. Okay, so this is a signed number. Okay, now the result should be ideally it should be 15. Okay, now this -5 is known as multiplicand. Okay, then 3 is known as multiplier. So -5 or multiplicand will be denoted by capital M and multiplier 3 will be denoted by capital Q. Now you need to understand what is N. N is the number of bits required to do this operation. Okay, now what it is? Suppose for this particular example, what I told just now, you have to multiply -5 with 3 in this particular example. So how many bits at least you need to have to do this Booth multiplication? So actually, if you see 5, how to represent 5 in binary? That is 101. Now how to get the -5 value in binary? You need to do second complement. So how to do? So first of all, you need to do first complement, then you need to do the second complement. Okay, to get -5. So do the first complement means that is 0, 1, 0, the complement of each of the bit. Then to do the second complement, you need to add 1. So the result is 0, 1, 1. But as I am using sign representation, I need to add 1 at the beginning to show this is a minus number. Okay, because I don't know whether you know or not. If it is a sign number, then you have to use 1 in MSB to show it's a negative number and 0 to show it's a positive number. So MSB has to be 1. If this is a negative number, MSB has to be 0. Then it represents a positive number. Okay, so as our number is negative, we have added additional 1 at the MSB to represent that this is nothing but a negative number. Okay, so you see how many bits were required to represent this -5 in case of sign representation? 4 bit. That 1 is to represent this a minus number, then 0, 1, 1. Okay, so you need 4 bits. So the value of N is nothing but 4 in this particular example. Okay, then come to the next. What is A? A is nothing but A is known as accumulator. Okay, A is known as accumulator. Okay, now the number of bits you need to consider in the accumulator, that is depending on whatever the value you have considered for N. So in this particular example, as you got N equal to 4, so you need to consider the number of bits present in accumulator, that is 4. So if you get n equal to 5, you need to consider 5 bits in accumulator. Okay. Now initially the accumulator value has to be 0. Means for this particular example, you need to use 4 zeros for accumulator. As I already told, if you have n equal to 4, then you need to use 4 bits in the accumulator, and to initialize a, you need to use 0000 at the beginning. Okay. Now what is Q0 that I will tell? Initialize means initially you need to take Q0 equal to 0 to do the initialization in this algorithm. Okay. So let me write down the bits. You need to write 10. You need to take the different contents of A. You have Q, capital Q. You have Q0 and you have to write some comment. Okay. Q0 I can write. Okay. This capital Q is further divided into 4 components for this particular example. Why? Because I need at least 4 bits to represent the number. As n equal to 4, you need to consider capital Q also 4 bits. So what are the bits? Q1, Q2, Q3 and Q4. Okay. Starting from LSB to MSB. Now the second number, whatever you have, that is 3, as this is your Q or multiplier. So generally 3, how it is represented as 0, 1, 1, all of you. Now in this case, as you have to use at least 4 bits, as your n value is 4, so you have to add another 0 here. Okay. So ultimately, how many bits you need to use? 4 bit, and this is the representation. Now you can write down each of the values. So initially I found out that n value has to be 4 and the accumulator value has to be nothing but 4 zeros. That I am doing the initialization, and how many zeros I need to give, that is depending on the value of n. Okay. Then Q, small q4, q3, q2, q1, what I need to write? 0, 0, 1, 1. Why? Because the multiplier is nothing but 3, and 3 is represented by this way using 4 bit. Now what is Q0? Q0 you need to consider 0 initially. Okay. So in this step, what you have done? You have done the initialization. Okay. Now after that, what you need to do? Depending on the value of Q1 and Q0, whatever the value of Q1 and Q0 you have, you need to take some decision. Suppose if the Q1 Q0 value is becoming 1 0, then you need to do A equal to A minus M. Means whatever the current value of accumulator is there, that you need to do minus M. Means M has to be subtracted from the current value of the accumulator if the combination is 1 0. If it is 0 1, the value of Q1 and Q0 is 0 1, then you need to do the reverse operation. Means you have to add the content of accumulator with multiplicand M. M is nothing but the multiplicand. Okay. And if it is 0 0 or 1 1, means the value of Q1 and Q0 is 0 0, either 0 0 or 1 1, then you need to do right shifting. Right shifting of what? Right shifting of A and Q content. Whatever the content is there in A and Q, that you need to do right shifting. Okay. And after that, you need to reduce the value of n by 1 unit. Okay. And you need to check whether n is becoming 0 or not. If it is 0, then you need to stop. Your result will be there in A and Q field. If it is not 0, you need to keep on iterating these steps. Means you need to keep on doing these steps again and again until your n becomes 0. Okay. And at the end, you need to stop. That is the entire algorithm. Now I will take this example and I will show you each of the step and how to get the result. That is also I shall explain. Okay, so this initialization I already explained. Now after that, you check the combination, means you check the value of Q1 and Q0. So in this case, let me write down here actually Q1 and Q0 value. So in this case, Q1 value is nothing but 1 and Q0 value is nothing but 0. So if it is 1 0, according to the algorithm, what you need to do? You need to do A equal to A minus M. So minus M value I am already having. Is it yes or no? Do I have A minus M? Because you know, if you have this value and this M value, So this is nothing but this value is nothing but the m value. Okay. If you have m value, can you easily find out the minus m value? Yes. So if m is this one, try to understand what I am saying. M is nothing but minus 5. So what about minus m? Minus m is nothing but 5 only. So how to represent 5? So how to represent 5? That is 0, 1, 1. 0, 1, 0, 1. That is the way to represent 5. Okay. And you know, as the value of n is 4, you need to take 4 bit. That is mandatory. If n was 5, then you had to take 5 bit to represent this number. Now, what I have done, as your m is minus 5. Now, if you want to get minus m, then the result is nothing but plus 5. Now, how to represent plus 5? All of you know that is nothing but plus 5 is represented by 0, 1, 0, 1. Okay, in binary. Okay, so as I was discussing, as the current value of Q1 and Q0 is 1, 0, I have to do A equal to A minus M. So what does it mean? In other way, I can tell that A minus or A plus minus of M. Both things are same. A minus M is just exactly same as A plus minus of M. Do I have the minus M value? Yes, that is 0, 1, 0, 1. Do I have the accumulator value? Yes, that is 0, 0. So if you add some number with 0, 0, the result will be nothing but the result of the other number. So this addition result, I need to give it to the accumulator because I need to follow this step. As the current result is 1, 0 of Q1 and Q0, I need to do A equal to A minus M. Now the current value of A will be becoming, after doing this operation, A equal to A minus M, the result will be nothing but you need to add the content of A, that is 0, 0, 0 with minus M. That minus M is nothing but 0, 1, 0, 1. So if you do the addition, that is nothing but the result will be same as it is 0, 1, 0, 1. Now this value you need to give it to the accumulator, means your accumulator will be updated. Now after that, what you need to do, as you come to this step, you need to do right shifting of the accumulator. Now how to do right shifting, that you have to be very careful. Okay, so in this case, we are doing this updation of A. Now there is no change of Q. Will be remain as it is. Now after that, what I need to do, I need to do the right shifting of A and Q. So you have to be very careful when you are doing the right shifting. The sign bit or the MSB bit will be remain as it is. Okay, if it is 0, it has to be 0. If it is 1, it has to be 1. So this will remain as it is. And 1 unit you need to do right shifting. So this 0 will come here, this 1 will come here, this 0 will come here, this 1 will come here, this 0 will come here, this 0 will come here, this 1 will come here. And this 1 will come here. Okay. So the result becomes this one. And one more thing, you have to do right shifting not only A and capital Q, small q0 also. That I forgot to tell. So when you are doing this right shifting, you have to do the right shifting of A, Q as well as Q0 also. So you see the last Q1 value, it does the right shifting and this value came here. Okay. So you can write some comment. In this case, what operation we have done? In this case, we have done right shifting of A, Q and Q0. And the previous case, what we have done that I didn't write actually, I have to do. That is A equal to A minus M. That operation I had done. Okay. So your this right shifting is completed. Now what you need to do? You need to reduce the value of n. So previously the value of n was 4. Now 4 minus 1. The updated value of n will be 3. Okay. Is it 0? No. Again, you need to repeat the step. So again, we need to repeat the step from here. Okay. Now what we need to see? We need to say what is the value of Q1 and Q0. That is 1, 1. Okay. So if it is 1, 1 or 0, 0, what you need to do? You have to do the right shifting of A, Q and small q0. So do the right shifting. And while doing the right shifting, your MS will be remain unchanged and remaining bit you need to do right shifting. 0 will come here, this 0 will come here, 1 will come here, this 0 will come here, 1 here, then 0 here, 0 here, this 1. So the value becomes 0, 0, 0, 1, 0, 1, 0, 0, 1. Okay, so here what we have done? Again, we have done right shifting. You can write the comment also, right shift of A, Q and small q 0. Okay. So after doing right shifting, what you need to do? You need to reduce the value of n. Now n value becomes again -1. So previously it was 3. Now it will become 2. You need to subtract another 1. Okay. And after that, you need to check n equal to 0. Still no. So again, you need to repeat the process. Now check what is the value of Q1 and Q0. That is 0, 1. So if it is 0, 1, then what you have to do? You have to go to this line. That is, you need to do A equal to A plus M. So your accumulator will be updated by the current content of accumulator, but plus the content of M or multiplicand. Okay. Now, what is the current content of accumulator till now? This is the content is nothing but 0, 0, 0, 1. And what is the content of multiplicand? You know, the value of M is nothing but the value of M is nothing but 1, 0, 1, 1. We have already calculated this value. It's multiplicand value. That is 1, 0, 1, 1. So do the addition 1, 1, 0, 1, 1, 0. 1 carry will come here. So this will be added. And this is the result you are going to get. Okay. So your accumulator will be updated by this value. So write down the updated value, that is 1, 1, 0, 0. So here till now you have not done any changes. So you come to this step. Your accumulator was updated by A plus 1. Now after that, what do you need to do? You need to do right shifting of A, Q and Q0. So do the right shifting. So while doing the right shifting, you have to be very careful. First bit will be unchanged and remaining bit you need to do right shifting. 1 will come here, this 1 will come here, 0 will come here, 0 will come here, this 0 will come here, 1 will come here, this 0 will come here, and this 0 will come here. Okay. Okay. So let me write down the operations also what we have done in the previous line. You have done equal to A plus M. Now in this case you have done right shifting of A, Q and Q0. Okay. Now after doing the right shifting, what you need to do? You need to reduce the value of n. So previously the value of n was 2. Now it will be reduced by 1 unit again. Now it becomes 1. Okay. Okay. Is it 0? No. Still it is not 0. Again, you need to do the operation. So in order to do the operation, you need to check the value of Q0 and Q1. So that is 0, 0. So you know if it is 0, 0, what you need to do? You need to do only right shifting. So do the right shifting. So as I am telling these things multiple times, this one will be same as it is. Your MSB you cannot change. Sign bit you cannot change. And remaining thing you need to do right shifting. This one will come here, one will come here, one will come here. 0, 0. This 0, this 1, and okay. So what we have done? We have done the right shifting again. Of A, Q, and small q. Now, what we need to do after that? N equal to n minus 1. The previous value of n was 1. 1 is subtracted from 1. So now the value of n becomes 0. So is it 0? Yes. Now we no need to do further processing what we have done in the previous cases. So as our n value is 0, we no need to do any further process. The result is already there in AQ field. In AQ field, whatever the current value is there, that is my result. I need to stop here. So this is my result. Now the question is how this is the result. So you know this first bit is 1. What does it mean? It means a negative number. So if it is a negative number, what do you need to do? You need to do the second complement to get the original magnitude. So find out the original magnitude. So this one is 0, this one is 0, this one is 0, this one is 0, this 1, 1, 1, and this 0. I have just done the first complement of this number. Now how to do the second complement? You need to add 1 with this result. So add 1. This becomes 0, 0, 0, 0, 1, 1, 1. Okay. And what is the magnitude? This is nothing but 15. 0, 0, 0, 0, 1, 1, 1, 1. What does it mean? It means that this number is nothing but it's 15 only. And as you have 1 in the MSB, it represents a negative number. So the result is minus 15. And theoretically also it was minus 15. And using this both multiplication algorithm also, we got minus 15. Okay. So this is the process. These are the steps you need to follow to get the multiplication of signed number using both multiplication algorithm. Thank you.